So this screencast is for anyone who was absent or my one class that didn't get it because my projector blew. So I'm going to kind of start somewhere in the middle with earthquakes. And when they're on the ocean floor, they can cause huge waves, cause tsunamis. These aren't tidal waves. Tides are created by are caused by the gravitational pull of the moon and the sun. The detection of most of these tsunamis are done with the same buoys that track El Nino. The um, biggest tsunami that we've ever had was the December 2004 Indian Ocean tsunami. I actually think it was December 2005, or it was 2004. It says 2005 in your notes, maybe. I forget. But it was a magnitude 1.5 earthquake, and 100-foot waves were felt at the shore. And what happens here is that you can see on the bottom here, when you have an earthquake, you have a subduction zone, and the one plate goes up on top of another one, and it creates this upward wave. And that's what then causes the disturbance at the surface. And it's like a drop in a bucket, as you can see from this one right here. This was the epicenter of the earthquake, and you saw the tourists. Oh, sorry. Well, right around here, the tourist in Thailand, on the western coast, got hit really, really badly with this tsunami. If you ever see the water, you run the other way because that is one of the indications that a tsunami is going to happen. The Japan quake and tsunami, you can see here the earthquake epicenter was really close to the Japanese coast, and that's why they got hit so badly. And you can see here, this was where the tsunami happened, but then here you have Hawaii right there, and they had tsunami warnings as well. By the time the tsunami, that wave got to Hawaii, it was only a couple feet tall. I think it was like 2 feet or something like that, but they still evacuated everyone because these tsunamis don't happen all the time. So we don't really know what their effects are and how these waves travel over the ocean. This is what it looked like in Japan. These are some of the images. Okay, before and after shots of just total destruction. And then we get to transform boundaries. These are the ones that slide past each other. Huge earthquakes. It's not a destructive or a constructive boundary. There's no seafloor spreading like in divergent plate boundaries. There's no subduction zone and melting of the plate as it goes down underneath the other. These plates slide past each other, and you have really violent earthquakes like the San Andreas Fault in California, which runs right through San Francisco and down through Baja. So if you notice the left-hand side, you can see the relative motion. So this plate is going this way, and the other one is going this way. Earthquakes, the magnitude is measured on a Richter scale. So the amplitude for each is 10 times greater than the next smaller unit. So Richter scale of 4 is 10 times greater than a 3, and the Richter scale of 4 is 100 times greater than a 2 because it's 10 times 10. There are aftershocks and foreshocks and primary effects and secondary effects. No one really ever dies from primary effects. It's the secondary effects. It's the fires, the flooding, the tsunamis. It's the buildings falling on people and stuff like that. Okay. So this will just show you the focus is under the earth, the epicenter is on the top. Those are, I think, vocab words, maybe not, but I won't ask those specific questions on a quiz. Right. So in the US, you see on the West Coast, there's a lot of risk. A little bit in the middle, there's much higher risk. And then if you look to new earthquake risk in the US, you have this batch here in the center, hello, that has showed up. Okay. And we can see, oh, I can't go back. Oh, nuts. Fracking. Okay, and we're going to talk about that a little bit later. In the world, you can see all along here, you're on a subduction zone. Okay, all along here, you have mountain ranges, you have volcanoes. In through the Middle East, and parts of Europe, especially Greece, very tectonically active. A hotspot is a stationary spot, and then the tectonic plate moves over it. Okay, the Hawaiian Islands is caused by a hot spot, and these are different hot spots in the world. And if you click on the link below, I know you can't in this, but I'm pretty sure that this is linked on Classroom as well. So this is new Hawaii down here, right? And what's happening is that this place in the earth is very tectonically active, or there's just magma constantly spewing up from the earth here, okay? Right, like this. And the Hawaiian Islands go all the way up over here, but these are the only ones that are above ground at this point in time. Okay, the rest of these were on the old hotspot, and the spot hasn't moved, but the tectonic plate has moved over time. In the US, we have a hotspot. The Yellowstone volcano is a hotspot, and it has erupted several times, and you can see a caldera chain. What a caldera is when a volcano basically blows its lid and then implodes on itself. It leaves like a big crater, like the most famous caldera, which is the Greek island of Santorini. And this is where they say the lost island of Atlantis was. And you can see from these pictures, you could see the different layers of volcanic eruptions and ash layers and stuff like that. Okay? And the whole towns, like the whole island is built on top of this caldera. And it's really pretty. So rocks and mining. Minerals, rocks, nothing new. We use a lot of minerals. They're metallic and non-metallic minerals. Ore is the rock that mineral comes from. There's high-grade ore and low-grade ore. High-grade ore was stuff I paid you guys $2 for in the cookie mining lab. Low-grade ore I paid you $1 for because me as a processor, I would have to refine that a lot more. Okay. We have 3 different types of rocks: sedimentary, igneous, and metamorphic. We used to go into a lot more detail, but we don't now. You need to know that igneous rocks are basically volcanic rocks. Sedimentary rocks are rocks that have formed from layers and layers of erosion settling in that area over time, and then they become rocks. And metamorphic are sedimentary rocks or even igneous rocks that undergo heat and pressure, but they're not melted like igneous rocks are. Most of our granites are metamorphic rocks, I think, or maybe they're igneous. I don't know. So stratigraphic columns, these tell you how far down, or how the further down, the older the fossil is, and these are usually in your sedimentary rocks. Okay, so we mine to remove mineral deposits. Surface mining is on the surface, and subsurface mining is below. Your overburden is your area of like your trees and your soil and stuff like that, and then your spoils are the waste materials, the material around the ore that you just don't need. So we have open pit mining, which is literally an open pit, mining in strips, contour strip mining, which is strip mining in contours, and then mountaintop removal, which is exactly what it sounds like. You obliterate a complete mountain. Deep pit, open pit mining, open pit, okay? And then here's your strip mining, shallow deposits near the surface, okay? You take those off in strips. This is a type of mining where you're taking these off in strips again. And then mountaintop removal, usually you have an area that's clear cut or burned. Your topsoil is removed, and then it's repeated blasting cycles over and over again to completely get all of the ore out of this area. It's done a lot in the Appalachian Mountains where a lot of coal mining is done. And you can see from these pictures just the devastation of before and after. Like, this is a massive truck right here. Like, take 4 school buses and kind of stack them into a square, and that's what that truck is. Okay, that's also what this truck is. So to actually get an idea of how big this is there's really no way to do it in pictures. Okay, so subsurface mining is what we typically think of. Room and pillar and longwall mining are 2 different types. You don't need to know the specifics of them, but this is what we think about when it comes to mining. This is the different shafts and your old time miners and carts and stuff like that, like this. And what ends up happening is a lot of these I think they're usually railroad ties, they're wooden. And what happens over time is that they rot and you get a lot of collapsing of these mines that are old and abandoned, but you have a lot of subsidence of the surface, which is the sinking of the surface. These are just some pictures of mining. This is actually the tunnel that is being mined underneath Manhattan right now for an aqueduct. Okay. Tailings dams, this is where we put our mining waste, and it's not considered hazardous waste, but it is hazardous waste. They're not, these are not Superfund sites. More than 300 tailings dams are high risk, meaning that if something happens to them, it'll cause human casualties. And you can see all along the Appalachian Mountains, this is where most of the high risk tailings dams are from coal mining. In 2015, there was a big gold mine spill, and the King Gold Mine had been shut down for a really long time, and that was before companies were required to clean anything up. And what happened is that they were cleaning it up and they sprung a leak, and that leak went into the Animas River, and the Animas River went down into the Colorado, and all of this, all of these toxins just were flushed out in through Lake Powell in the Colorado River. Okay, so these environmental impacts of mining, it disturbs a large area. You have subsidence or collapse of land above, like I just said. It uses large quantities of water. You have to pump water out of the mine to keep it dry because the water is constantly trying to get down to the lowest point. You have something called acid mine drainage, which is when water gets into the mine, it combines with sulfuric acid, lead, arsenic, cadmium. It washes out of the mine into nearby waterways. Okay, so you can see here your subsidence. This row of like piano key looking things is the old mine, and this area collapsed, which means this area above it is also going to collapse, and that's subsidence. Sometimes it's severe, sometimes it's not. Processing minerals is smelting. The ore is melted at high temperatures. It separates impurities from molten metals. It emits air pollution, causes water pollution. It causes liquid and solid hazardous wastes. And the very specific thing about gold mining, which is why the Gold King mine spill was such an issue, is because we used to use a lot of cyanide to get the gold out of the ore in a process called cyanide heap leaching. And so a lot of these toxic substances now are stored in these tailing dams, and that's when the EPA was trying to clean it up. You had a lot of cyanide from that gold mine, along with cadmium and arsenic and other really bad things. Right. So the General Mining Law of 1872 basically said until 1995 you could buy land in the U.S. at really super cheap prices, like 1872 prices, and as long as you were going to mine on it, then that was cool. And in 1992, so not too long ago, the General Mining Law of 1872 was modified so that now companies have to pay for cleanup. I don't know where SMRCA went, the Surface Mining Control and Reclamation Act, but Mr. Anderson talks about that, and it's in your study guide. You guys also need to know that law, which basically says that companies must pay for cleanup. Okay? When we're restoring mining land, we want to prevent further degradation or damage. You want to make land productive for another purpose. It's never going to be exactly what it was, but you try to make it better. And a huge way to do that is through establishing wetlands and phytoremediation, so using specific plants to actually clean up that pollution. At Liberty State Park up near Liberty Science Center, there was a big area that was polluted with cadmium or some sort of toxin, and birch trees take in that toxin. They have a high affinity for cadmium or chromium or something like that. And so what they did was a 25-year planting of these trees, where these birch trees grew relatively fast, and they sucked up a lot of the cadmium from the soil. Then all these trees were cut down and sent to a hazardous waste facility. Okay. So here's ecological mining site in Indonesia, very rare, but still it's pretty awesome. Fracking is a type of mining where you go down into the earth and you explode, you set off these small explosions, and then you mix some water mixture in with whatever it is that's down there, and you suck it all back up, and then you get out your goal is to get out, whether it be gas or oil. And it's a big issue, and it's causing a lot of earthquakes in the Midwest. And we're going to talk about it more, but I just want you guys to know the concept of hydraulic fracturing now. Okay? And last but not least, these are your non-renewable completion curves. And this is the time that it takes to use up a certain percentage of a mineral, like a resource at a given rate. You don't need to know the specifics of A, B, and C, but you do need to know that if we don't use our resources wisely, we're going to use them up very quickly. However, if we use them more wisely, we recycle, we reuse them, we reduce the consumption, then they're going to last for longer. All right, just another tip that there are 5 questions from your Bozeman environmental economics video, the geology, and then the mining Bozeman videos are really awesome to watch. And as always, study your Quizlet.